Okay. So from this question 1, question 1A, draw the block diagram of figure 1 when the performance requirements for heating of a residential building are not very stringent. Okay, so soalan uh, this kind of question is common for topic lecture 1. Okay, so you are required to draw a block diagram and then uh, justify whether the system is either open loop or closed loop, and then redesign the block diagram to change it from maybe from open loop to closed loop. So before we can answer or draw the block diagram, first thing is we need to identify the components of this system according to what we have learned last week. So control system has several elements as what we have looked last week. Okay, so let's identify the elements of the control system based on this figure. Okay, so from the description, it says that um, the desired temperature is the command input. Okay, so we know that the input is the desired temperature, and then this input is controlled by this dial, calibrated dial, meaning that when we adjust this dial, then the valve position will change and release the steam boiler into the radiator or into the room. So we have a controller here, which is the dial or the valve. And then the steam boiler will release gas, okay, into the radiator, which is located in the room. So we have maybe subsystem, the radiator, and the plant or process. So plant or process is the place where everything occurs. So here, the plant or process is the room. And then the output will be the actual room temperature. Okay, and then when we want to draw the block diagram, we need to identify first whether this is an open loop or closed loop. So based on description, if you look at the last sentence, when this value changes significantly, then the control temperature will deviate from desired value by a large error. So here, it want to show that whenever there's a disturbance from the external environment, then the actual room temperature will change significantly and will not be will produce large error compared to the desired temperature. So this kind of system that are easily affected by external disturbance is open loop system. Okay, based on what we have learned last week. So we know that this is an open loop system. Then we can draw the block diagram. using the components here. Okay, so we start with input. So desired temperature. And then it will go to the dial or the valve. And then from the valve, it will allow this the heat, the steam to go into the radiator. And then the radiator will heat the room. And then from the room, we get the actual room temperature. Okay, so this is the block diagram for question A.
Sir,
Kalau
contoh kan kita letak depan ni desired temperature, lepas tu valve tu kita letak steam boiler, lepas tu baru valve. Boleh ke?
Okay. Boleh je kot. Boleh je rasanya. Well, basically it should be everything that yang listed here, okay? Everything that is listed here, which is the element, okay? Elements of control system. Okay, steam boiler is part of the element, should be part of the element because it releases the heat. But in the end, if let's say if similar question come out in exam, the panel or the examiner will try to find all the things that should be in the block diagram. For example, like you must have the plant here, plant, and then controller, input, output, and maybe the actuator. So usually there will be these 5 things, okay? If you add extra things, it's okay. It should be okay as long as you have all the 5 things in your block diagram. Okay, let's look at question B. So identify the system either as open loop or closed loop. And then justify your answer. Okay, so basically question B, the answer is already given by the last 2 sentences. Basically, from the last 2 sentences, the valve dial is calibrated when the environment temperature has certain value. And then when this value changes significantly, the control temperature will deviate from desired value by large error. So it is an open loop system. So maybe you can say that because the room temperature changes significantly when the external environment temperature changes. Okay, so this sentence indicates that the system easily affected by external disturbance. So if you still remember last week, open loop system is easily affected by external disturbance, while closed loop system, because it has the feedback portion of the in the block diagram. So whenever there is a disturbance, then it will try to reduce the effect of disturbance by calculating the error. Okay, so in this system, uh, whenever there is a disturbance, then the actual temperature, the room temperature, will change significantly, and you need to calibrate the dial so that you can overcome or reduce the effect of environment temperature. So another reason is you need to calibrate the dial to reduce the effect of environment temperature. So last week we have looked at open loop system that it requires calibration every time for every use. Compared to closed loop, we don't need to calibrate the system. Okay, then question C, design another block diagram if the system is converted to a closed loop system by adding the functions of measurement of the controlled temperature, and then comparison of measured and desired value of the controlled temperature, and control logic to make changes in the heating rate when the desired and measured values differ. So in this question, it says adding three things. Okay, so the first thing is function of measurement of control temperature, and then comparison of measured and desired value of temperature, and the third one is control logic. So you need to add three more things. Okay, so the first thing is you need to add something that can measure the temperature. So what are the things that can measure the temperature? So you need to be specific. Okay, you cannot just write a sensor. So sensor, it's common. Okay, like it's too general. You need to be specific on what kind of sensor that can measure the temperature. So you can just put maybe temperature sensor or thermometer. Okay, so you need to add sensor, which is thermometer, and then number two, you need to add a comparison of measured and desired values of the controlled temperature. So this second point here, basically, uh, the question wants you to add the circle with cross symbol as what we looked last week on closed loop system. So you need to add this thing in your block diagram. Okay, so we will look more later on this thing, maybe in chapter 3. Okay, what are this thing? What is this thing? The circle with cross. But for now, you need to remember that this circle with cross only exists in closed loop system. Uh, commonly exists in closed loop system, and the function is to compare measured and desired values. And then lastly, you need to add control logic. Okay, so you need to add another controller that the name given is control logic. So you need to add controller, control logic. Okay, so basically you need to modify the block diagram from question A to add these three things, 1, 2, 3. Okay, so let's modify. So first is desired temperature. And then we will go to the circle with cross. And then we go to maybe control logic. So whenever there's a difference between the temperature, the control logic will calculate the difference, okay? And then it will change the position of the valve based on the error calculated. And then it will go to radiator, to the room, and then to the room temperature. Then we need to add the thermometer at the feedback loop, okay? And then this one will be connected to the circle with cross. Okay, so this is the answer for the block diagram of closed loop system. Okay, any question before we move on to next question?
No, sir.
Okay, thank you. All right, now we move on to question number 2. Okay, so question number 2 is quite lengthy. Okay, so the open loop TCFI twin cam fuel injector system has inputs for RPM, throttle positions, and cold start related variables. Fuel lookup tables translate these inputs into a predetermined fuel injector pass width. The fuel injectors then deliver fuel to the engine. The overall accuracy of the system is dependent on the lookup tables and fuel injectors. If the lookup tables are not correct or the fuel injectors become clogged with deposits over time, engine operation will suffer. With a closed loop fuel system, a feedback path is added to allow the system to make correction. In the case of the TCFI system, wideband oxygen sensors measure the actual engine air fuel ratio. The system compares the AFR command from the fuel tables to the measured AFR from the sensors. The difference between the FR command and the measured AFR is referred to as the AFR error. The system slowly makes correction to the injector pulse width to drive the AFR error to 0. These corrections are stored in a block learn multiplier BLM table organized into RPM and TPS cells. The BLM table is continually updated. When engine operations shifts to a new cell, the system can use the BLM value last saved in the cell as a starting point for further correction. Over time, the system will learn the BLM value required for every cell in order to drive the FR to 0. This process is referred to as auto-tuning. Okay, and then based on explanation, draw the open and closed loop block diagram. Okay, so we draw the open loop first. So the open loop, basically the description is from the beginning until until the word suffer here. Okay, so as usual, we need to identify the components of the control system before we can draw the block diagram. So first, we need to identify the input. So here, the system has inputs. So ada banyak. So there are many input. RPM, throttle position, and cold start variable. So there are 3 inputs for the system. So we have RPM, throttle position, and cold start variables. And then this input into a predetermined fuel injector pulse width lookup table. Okay, so there is a lookup table that take this input and produce one output from the input. So maybe we can put the lookup table as something like a controller. So lookup table. And then it will go into a predetermined fuel injector pulse width. Okay, so the subsystem consists of fuel injector. Okay, so based on the input and the lookup table, it will tell the fuel injector to release certain amount of fuel. And then from fuel injector, we have the plant. So the plant is the engine. Okay, so everything occurs inside the engine. And then lastly, we need to find the output. So the output will be so maybe it will be the same as AFR, or maybe the amount of fuel released into the engine. Actual amount of fuel. Okay, so from here, then we can draw the block diagram. So we have RPM, throttle position, and cold start variable. So we have three inputs. So it must be combined. Okay, combine these three input, and then it will take by the controller, the lookup table. And then from the lookup table, it will tell the fuel injector the amount of fuel need to be supplied to the engine. Then we get the actual fuel. Okay, so this is the open loop system. And then the question also asks you to draw the closed loop system. So the closed loop system starting from the word with until the end. Okay. So in the closed loop system, it says the system has a feedback path in which a sensor known as wideband oxygen sensor that measure the actual engine air to the fuel ratio. So we have a sensor, wideband oxygen sensor. And then the system also compares the AFR command from the fuel table to the measured AFR from sensor. So there will be a cross, circle with cross. And then the difference between the AFR command and the measured AFR is referred to as the AFR error. The system slowly makes correction. These corrections are stored in a block learn multiplier table. Okay, so instead of using lookup table, we have a new table known as block learn multiplier table. Okay, so another subsystem or controller lah. Controller, we call it BLM, block lookup, block learn multiplier. And then when engine operation shift to a new cell, the system can use the BLM value last saved in this cell as starting point. Over time, the system will learn BLM value required for every cell. Okay, so basically you add these three things: sensor, the circle with cross, and also BLM. Okay, so you just need to modify from the open loop system block diagram by adding these three things. So we have RPM, TPS, and cold start variable. Okay. And then it will go to BLM, the block learn multiplier. Okay, so instead of using lookup table, we use the block learn multiplier. And then we have the fuel injector. The engine. And the output is AFR, and air to fuel ratio. Okay, so we have a sensor. We call it wide band oxygen sensor. So it measure the AFR and compare it with the input. Okay, so something like this, the answer. So you must have a sensor, a feedback loop, and the circle with cross. Okay, so you must have this thing, this feedback loop, and sensor to make it a closed loop system. Okay, any question before we go to question number 3?
No, sir.
Okay.
Sir,
Yes.
kan yang open loop tu macam mana kita tak tahu yang kita ada juga cross tu? Kan yang saya tulis tu.
Oh, okay. Okay, so cross usually only comes in closed loop system. But in this case, we have more input. Kita ada input lebih dari satu. So bila kita ada lebih dari satu input, kita kena macam combine lah. We need to combine all the inputs to make it into single input for the system. So the purpose of this thing, cross circle with cross, is basically to combine, okay? To compare or combine. Okay, so in this case kita ada 3 input. So kita compare, bukan compare lah, kita combine dia orang. And then jadikan dia satu output kat sini. So ada 3, 1, 2, 3. Combinekan dia dekat circle ni. Kita akan dapat satu anak panah or arrow. Represent the output. Okay, so later on kita akan tengok lagi apa benda circle with cross ni dengan lebih detail. Tapi for now dia adalah satu macam simbol. That is the purpose of this circle with cross is to combine or to compare two different inputs, okay, to make it into single output. Okay, so here we have 3 input combined and then we get one single output. Okay, so let's look at question number 3. A schematic for a car cruise control is given in figure 2A. Okay, question A, complete the block diagram in figure 2B by identifying each of the components. Okay, so in figure B, we have a control device with a blank box, and then actuator, blank box, and we have a car body, but no label, and then we have the dot, 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 dot at the end here. So basically, we need to identify what is the control device, what is the actuator, car body, what car body is represent as, okay, and then we have the dot, the dotted here represent what is the actual things that we need to measure. Okay, so from the car, it's a car system for a car cruise control. So car cruise control basically a system that automatically controls the car speed. Okay, so in this figure, we have a desired speed. Let's say we want to drive at 80 kilometer per hour. So we have to control something. So control device, what is the device that we need to control to ensure that we get the desired speed? So in this figure, we have car body, engine, electronics, and throttle pedal. So to control the car speed, we need to press the pedal. So pedal is the control device. So control device is the pedal. And then after we press the pedal, then something will happen. Either before the tire increase in speed in rotation, something happened before the rotation increases. So the actuator. So after we press the pedal, then the actuator will take the action. So from the figure, after we press the pedal, then the engine will work harder, okay, according to the amount of pressing, okay, on the pedal. So the actuator is the engine, and the car body is the place where everything takes place. So car body is the plant or process. Okay, so the dotted here represent the speed, the actual speed. After we press the pedal, then the engine increase in its performance. Then the car body will move. Then the actual speed is the speed uh, uh, produced by the car. Okay, it might be the same as what you want, what you desire based on your pressing on the pedal, or it might be different. Okay, so the last one is the actual speed. Okay, so this is the dot 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 dot. Okay, question B. In your opinion, how can we redesign the system to make it a closed loop system? And then name one component to add to the system, then redraw the block diagram. Okay, so this system is an open loop system because it doesn't have any feedback. So how to improve to make it as a closed loop? So we need to redesign. So to make it as a closed loop, we need something that can measure the actual speed of the car. So in an open loop, in the system in figure B, you cannot measure the speed, the actual speed, because there is no component that measure the actual speed. So to make it closed loop, you need to add something that can measure the actual speed. So to make it closed loop, add a subsystem to measure the actual speed. Okay, so what is that component that can measure the actual speed? So we need to add a sensor. So what sensor? So it's better if you be specific. So in this case, for car, to measure the speed of the car, we add a tachometer. Or paling-paling cikai, speed sensor lah. Okay. Okay, so we have the tachometer or speed sensor added. Then we need to redraw the block diagram. Okay, so just add the tachometer into the figure B. So we have desired speed. And then we have the pedal. And then engine. And then car body. And then the actual speed. So we have tachometer as a sensor. Okay, so kena ada kat sini cross, circle with cross. Okay. Okay, question C. Discuss the advantages of using closed loop system for car cruise control. Okay, so this is a common sense punya answer lah. Okay, so why what is the advantages of having a tachometer? Is that we can control the speed of the car so as to make sure it to be the same as what we desire. So for example, let's say you drive on a highway. So on a highway, the speed limit is 100, let's say 110 kilometer per hour. But so you want to drive at 110 kilometer per hour. But in your tachometer, dekat dashboard tu, your car speed, the actual speed, the reading indicates that the car speed is maybe 90 kilometer per hour. So from the reading, you press more because you know that your car speed is less than what you desire. So you press more to make it 110 kilometer per hour. So that's the reason of having a tachometer or closed loop system, so that you can drive the car indicating or providing the value of error or difference between your desired car speed and the actual car speed. Okay, so that you drive according to what you want. Okay, according to what speed you want. Okay, so jawapan dia pandai-pandai lah tulis. Okay. Okay, question D. Identify and describe one disturbance that may affect the system. Okay, so this thing is you need to identify a disturbance that may affect the speed of the car. So apa benda? So what are the things that may affect the speed of the car? Maybe ada angin lintang. There's a wind flowing from the front to the back. that making your car slow, okay, or reduce the speed of your car. Or maybe you drive on a bumper. So when you drive on a bumper, your car, the speed is reduced because of the bump, okay. Or you have to reduce the speed, okay, so that the car is not damaged when moving over a bump. Or maybe you drive on a road that is maybe has high friction. Maybe you drive on a gravel, okay, jalan yang ada batu kerikil, not on a tar road, okay. So when you drive on a road surface that is not smooth or maybe has a higher friction, then your car speed will reduce. So just identify one, maybe friction off road, or drive uh, over a bump, or wind effect. And then you describe how these three disturbance or one of the disturbance affect the system. So the friction will reduce car speed, or actual car speed. So it reduced the actual car speed. So let's say you desire to drive 110 kilometer per hour, but you press and then the tachometer reading also indicates 110, but you feel that your car is driven slower than 110. So what you did is maybe you press more, okay, you press more on the pedal to increase the speed, okay. So maybe the indicator shows the speed is correct as what you desire, but maybe rasa macam slow, okay, kereta tu slow. So the effect of friction, it reduces the actual car speed, so it causes you to increase the speed by increasing the push on the pedal. So you push more on the pedal to increase the car speed. And same thing for driving over bump and the wind effect, okay. So if the wind is flowing from the back, then you find that your car is slightly faster than what you desire, so you will push less on the pedal so that the speed of the car is reduced. Yes, betul lah. Okay. So just describe in your own word lah. Okay. Okay, so that's for tutorial number 1. Any question before we move on to tutorial number 2?
Sir,
Yes.
kalau disturbance tu signal boleh?
Disturbance.
Kalau saya buat yang signal, disturbance signal.
Signal apa tu?
Signal, kalau signal yang tak menentu.
Tak boleh, dia kena be specific lah. Contohnya signal apa, macam tu.
Oh, okay.
So dia kena try to be specific. So tak bagi signal macam mana? Contohnya macam orang kat pekan tiba ada kereta nak masuk UMP, dia main masuk je, tak bagi signal ke kanan. Boleh juga, tapi maybe janganlah bagi spesifik macam tu pula, macam case pula. Maybe we can say that there's ada halangan ke kat depan, okay. There's a halangan, apa halangan in English? Tiba jadi tak pandai English. Okay, ada halangan ke kat depan? For example, some other cars in front giving a signal to turn to left or right. Okay, so you give example. So bila ada halangan, kita akan reduce the car speed. Okay, bolehlah acceptable lah kot. Okay, so that's it for tutorial number 1. So let's look at tutorial number 2. Okay, so tutorial number 2 will be about lecture 2A, introduction to transfer function. Okay, question number 1. Given the ODE of a system with initial conditions below using Laplace transform and partial fraction expansion, determine YT. Okay, question A. Okay, kita tengok question A dulu. Okay, so the initial condition given is at time 0, the value of y is 0. So this indicates that you can convert the equation into frequency domain without using the additional extra things, okay, in the based on the lookup table, based on the table in lecture 2A. So for example, if you use Laplace transform, okay, convert using Laplace transform. So y double prime, you get s squared big ys. Okay, so ada extra terms tu. So yang tu boleh ignore lah sebab there's the initial condition given is 0. So you can ignore the extra things, okay? So here 5y prime, you get 5s big y s. And then 6y, you get 6ys. And then 1. So 1, if you convert into frequency domain using Laplace transform, you get 1 over s. Okay, and then now you need to rearrange the equation to get y, okay, to get the big y. So ys factorize, so you get s squared minus 5s plus 6 equals 1 over s. Okay, and then rearrange, you get ys equals 1 over s multiplied by s squared minus 5s plus 6. Okay, now you need to use partial fraction expansion. So first thing you need to do is you need to factorize this. Okay, so you get 1 over s multiplied by s minus 3, s minus 2. Okay, boleh check balik. Betul tak? So you get s squared minus 3s minus 2s plus 6. Okay, it's the same. Then you can split the fraction into three partial fraction. Okay, so you get a over s plus b over s minus 3 plus c over s minus 2. Then you can use the method in lecture, or another method is simplify the fraction, the new fraction here, into one single fraction. So you get a times s minus 2 s minus 3 plus bs s minus 2 plus cs s minus 3 divided by s times s minus 3 s minus 2. Okay, so you can equate, okay, samakan yang atas ni dengan ni. So you get a times s minus 2 s minus 3 plus bs s minus 2 plus cs s minus 3 equals 1. Then you need to find value of a, b, and c. Okay, so to find value of a, you need to substitute s. So let's say we use s equals 0. So when we use s equals 0, then this becomes 0. And this also becomes 0. So we only have the first part here, a only. So you get a, substitute with 0, you get -2 and -3 equals 1. So you get a equals 1/6. And then we want to find b. So we substitute with s equals 3. So we get b times 3 times 1 equals 1. So you get b equals 1/3. Okay, so to find c, you substitute s equals 2. So c times 2 times -1 equals 1. So c equals -1/2. Okay, so you substitute the value of s yang menjadikan salah 2, okay? Dari 2 daripada 3 ni sama dengan 0. Okay, so after you get all the value a, b, c, substitute back into this equation. So you get ys 1/6 over s plus 1/3 over s minus 3 plus -1/2 over s minus 2. Okay, so we get ys. The question wants yt. So we use inverse Laplace transform. Okay, inverse Laplace transform. So you get yt equals 1/6 plus 1/3 e power of 3t plus or minus 1/2 e power of 2t. Okay, so this is the final answer. Okay, any question before we move on to question B?
Boleh doktor, boleh.
Yang y0 equal 0 tu apa function dia?
Okay, so ni back to our lecture notes lah. So sebenarnya when you convert y double prime using Laplace transform, kita akan dapat s squared y prime ys plus something ni plus ada something lagi based on the table, okay, dalam lecture notes. Okay, so when we have this y00 ni, kita assume yang ni semua ni kosong. Okay, so most of the time dalam control system lah sekurang-kurangnya kita akan bagi initial condition yang ni y0, 0. Tapi kalau dalam subject maths, mungkin condition dia lain. Okay, sebab dia nak korang guna ni. Dalam ODE belajar kot Laplace. Tapi dalam control system, kita assume y00 ni. Okay, so basically, secara mudah cerita, y double prime, Laplace transform, jadi s squared, big Y, S. Okay, abaikan yang depan ni sebab initial condition ni. Okay, saya harap semua okay. Saya harap semua tak mengantuk. Okay, let's look at question B. So we have y double prime minus 3y prime plus 2y equals 2. Okay, cara yang sama, we convert this into frequency domain using Laplace transform. So we get s squared ys minus 3s ys plus 2ys equals 2 over s. And then rearrange, you get ys, okay? So ys S squared minus 3s plus 2 equals 2 over s. And then ys equals 2 over s multiplied by 1 over s squared minus 3s plus 2. Okay, factorize. You get 2 over s minus 2, s minus 1. Okay, you can check s squared minus 2s minus s plus 2. Okay, same. And then separate them into partial fraction. You get a over s plus b over s minus 2 plus c over s minus 1. Okay, simplify into a single fraction. A times s minus 2 s minus 1 plus bs s minus 1 plus cs s minus 2 divided by s minus 2 s minus 1. Okay, compare this with this. So you get a s minus 2 s minus 1 plus bs s minus 1 plus cs s minus 2 equals 2. So find a. So assume s equals 0. So you get a times minus 2 minus 1 equals 2. So you get a equals 1. So find b. So assume s equals 2. So b times 2 times 1 equals 2. So b also equals 1. And then lastly, find c. So assume s equals 1. So c times 1 times minus 1 equals 2. So you get c equals minus half. Then substitute back into the partial fraction. So you get ys equals 1 over s plus 1 over s minus 2 plus negative 1 over 2 over s minus 1. Okay, so you need to find yt, use inverse Laplace transform. So 1 over s, you get 1 plus 1 over s minus 2, you get e power of 2t. So minus half et. Okay, so this is the final answer. Ada soalan ke? Ya. Siapa yang angkat tangan?
Saya.
Ya, boleh tanya je.
Yang C tu bukan negatif 2 je.
Okay, salah. Pandai tiba.
Okay, thank you sir.
Thank you. Okay. So konsep dia guna Laplace transform untuk tukar ODE ke frequency domain. You use Laplace transform to change the ODE into frequency domain and then rearrange to get ys, and then use partial fraction to split the fraction, and then use inverse Laplace transform to get yt. Okay, so question number 2. Consider a system described by the differential equations. Find the system response yt to an input rt equals e power of minus tut, assuming 0 initial conditions. Okay. So kita tulis dulu y double prime t plus 7y prime t plus 10 yt equals r dot RT plus 3RT. Okay, so we use Laplace transform to convert this equation into frequency domain. So we get S squared plus 7 SYS plus 10YS equals. So convert the R into frequency domain as well. So we get SRS plus 3RS. So first thing, after that, we need to rearrange them to find the transfer function. Okay, so the transfer function is the output over input. Okay, so transfer function is output over input. So here the input is R, given in the question, input R. So Y is the output. So we need to rearrange the equation into output over input. Okay, so firstly, factorize S squared plus 7S plus 10 equals RS times S plus 3. Okay, then we find the transfer function. So output over input equals S plus 3 over S squared plus 7S plus 10. Okay. Okay. Now we have YS over RS, but the question wants you to find YT. So it gives you RT. So RT equals E power of negative T. Okay, UT tu boleh abaikan lah. Okay. So what we need to do is we need to convert RT into frequency domain. So we get RS equals 1 over S plus 1. Okay. Then substitute this into the transfer function. So you get YS equals S plus 3 over S squared plus 7S plus 10 times RS. Okay, substitute. So S plus 3 divided by S squared plus 7S plus 10 times S plus 1. Okay. Now from here, you need to factorize this and then split them into partial fraction. So you get S plus 3 divided by S plus 1. So here you get S plus 5, S plus 2. Okay, boleh check. So you get S squared plus 5S plus 2S plus 10. Okay, sama. Then you split them into partial fraction. So you get A over S plus 1 plus B over S plus 5 plus C over S plus 2. Jangan carut.
Apakah? Lol.
Apa sir?
Lapar tu.
Kata apa ni sir?
Sabar. Tak ada lagi.
Lain macam.
Siapakah itu sir?
Bapak.
Sabarlah. Sabarlah. Sekejap lagi boleh makan. Okay, teruskan. Okay, A darab S plus 5, S plus 2 plus B times S plus 1, S plus 2, plus C times S plus 1, S plus 5. Okay. Okay, jalan kira saya panjang sikit lah. Kalau ada jalan kira lagi ringkas, boleh je. Ya, asalkan jawapan dia sama. Okay. Now we compare this with this. Okay. Okay. Now we need to find A, B, C. Okay, so to find A, we substitute S equals minus 1. Okay, so if you substitute S minus 1, this part will become 0 and this part also becomes 0. So you get only A. So you get A times 4 times 1 equals 2. Okay. So you get A equals half. Okay, next to find B, you substitute S equals minus 5. So minus 5, B times minus 4 times minus 3 equals minus 2. So you get B equals minus 1 over 6. And lastly, S equals minus 2. So you get C times minus 1 times 3 equals 1. So you get C equals minus 1 over 3. Okay, substitute back into the original equation. So you get YS equals 1 half over S plus 1 plus 1 over 6 over S plus 5 plus 1 over 3 over S plus 2. Okay, so now you can use inverse Laplace transform to get YT. So the first one you get 1 half E power of minus T minus 1 over 6 E minus 5T minus 1 over 3 E minus 2T. Okay, so this is the final answer. Okay. Any question before we end this lecture and pergi makan? Dah lah rakam. Aduh. Okay, so if you don't have any question, then I hope you can understand the basic concept of control system and also how to use Laplace transform and partial fraction. Later on, maybe in chapter 3, we will revisit on the use of Laplace transform and how to find the time response or YT, how to find YT using partial fraction and Laplace transform. Okay, actually there is a quiz already uploaded in Kalam, but the quiz will be released on Friday, I think. Yes, on Friday. So please be reminded, okay, on Friday buka Kalam, okay. So jawab quiz tu dalam Kalam. Saya rasa there is a document uploaded and the document is released on Friday and I think the due date is Sunday. Okay, so quiz bukan saya buat. So please open Kalam and look for quiz on Friday, okay? And submit before Sunday midnight, before Sunday 11:59. Okay, so that's it for today's tutorial. We will continue our lecture on Wednesday with new topic, okay? If you have any question, do not hesitate to ask in our WhatsApp group. Okay, that's all. Thank you very much. Assalamualaikum and goodbye.
Ni ke saya? Dah boleh makan dah tu.
Sekejap tutup rakaman.